Hi everyone, I am Dr. R. Soumya, Assistant Professor, Department of Electronics and Communication Engineering. The subject is Artificial Intelligence and Machine Learning. Unit 3 is the Supervised Learning. Here we are going to see the topic about linear classification models. Objective: to understand the concept of linear classification models. The linear classification algorithm that makes its classification based on the linear predictor function combining a set of weights with the future vector. A linear classifier does classification decision based on the value of linear combination of characteristics. Imagine that the linear classifier will merge into its weight all the characteristics that define a particular class. Linear classifier can represent a lot of things, but they cannot represent everything. The classic example of what they can't represent is the EXAR function. Discriminant function. The linear discriminant analysis is the most commonly used discriminant reduction technique in supervised learning. Basically, it is the pre-processing step for pattern classification and machine learning application. LDA is a powerful algorithm that can be used to determine the best separation between two or more classes. The linear discriminant analysis is a supervised learning algorithm, which means that it requires a labeled training set of data points in order to learn the linear discriminant function. The main purpose of linear discriminant analysis is to find the line or plane that best separates data points belong to the different classes. The following steps are used for the linear LDA algorithm. The first step is to calculate the means and standard deviation on each feature within class scatter matrix and between the class scatter matrix is calculated. These matrices are then used to calculate the eigenvectors and eigenvalues. LDA chooses the k eigenvectors with the largest eigenvalues to form the transformation matrix. LDA uses this transformation matrix to transform the data into a new space with k dimensions. Logistic regression. The logistic regression is a form of regression analysis in which the outcome variable is binary or distortments. The statistical method used to model distortments or binary outcomes using predictor variables. Logistic component. Instead of modeling the outcome y directly, the method models the log odds y using the logistic function. Next one is the regression component. Methods used to quantify the association between an outcome and predicted variables. It could be used to build predictive model as a function of predictors. In simple logistic regression with one predictor variable, logistic regression. So this is the formula for the logistic regression. With the logistic regression, the response variable is an indicator of some characteristics, that is 0 or 1 variable. Logistic regression is used to determine whether other measurements are related to the presence of some characteristics. For example, whether certain blood measurements are predictive of having a disease. Logistic regression. This is the sigmoid curve for the logistic regression. The linear and logistic probability models are given below. The first equation shows the linear regression model and the second equation shows the logistic regression model. The linear model assumes that the probability P is a linear function of the regressors. while the logistic model assumes that natural log of odds p of p by 1 minus p is it is the linear function of regressors. Advantages: it is interpolability. In linear model, if the 1 is 0.05, that means that 1 unit increases in x1 is associated with the 5% increase in the probability that y is 1.